Hello everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. The topic for discussion today we have selected problems on inverse Laplace transform. In detail we will discuss about what are the formulas related to inverse Laplace transform and the problem based on inverse Laplace transform. These both subtopics we will discuss. So this is the given problem, that is find L inverse of s square plus 2s minus 4 divided by s minus 5 into s square plus 9. This how to solve. First, the related to L inverse. What are the formulas? What are the theorems related to inverse Laplace transform? It is there. Just we will recollect those formulas first. Then, which formula is suitable for this given problem we can select. The first one, we are thinking elementary functions. The elementary functions, we know it, small formulas, L inverse of s by s square plus a square is the standard formulas, that is cos at. Similarly, L inverse of a by s square plus a square. So sin at. L inverse of s by s square minus a square cos h at. L inverse of a by s square minus a square sin h at. So the similar way, L inverse of 1 by s minus a equal to e power at. These are all the elementary functions related to this inverse Laplace formula. So only this is fit for this. And the down part is there, s square plus 9 is there. But the s square plus 9, but if you are noticing, the numerator either s or it is dominating in this elementary functions inverse formula. Totally elementary function which is ruled out for this problem. So next, this all the decisions we have to take the fraction of seconds which is suitable. The first shifting theorem of this inverse Laplace, that is, we know very well, that is L inverse of f bar of s, it's nothing but f of t. If s place instead of s, if it is s minus a, then we can put in this format. Then we are thinking in this given our problem, s minus 5 is there. Then this part can be written as, according to this, e power 5t we can write. But what about the remaining terms? It is very difficult to solve this using first shifting theorem. Directly it is not possible. So now we are moving whether it is possible second shifting theorem. So like this doing, we are going to, what are the formulas, inverse formulas, once we are going to recollect it. So these formulas using only the entire problems to be solved. Now our f bar of s, if it is multiplied by e power minus as, then the final result will be f of t minus a into h of t minus a. Fine. This f of t minus a is there. First we have to extract from the given problem f of t we have to extract. F of t, which is nothing but L inverse of f bar of s. It is very difficult f bar of s to select, because if it is a single term, and the main problem with the numerator, our standard formulas are either s or a will be. So this is also not possible. The second shifting theorem also, it is not to apply for this our given problem. So the next related to our inverse Laplace transform, change of scale property. The change of scale property, it is nothing but now s is there. If that s is multiplied by a, if it is in the format of as, yeah, it is here, the numerator, the 2s, it is there. But if it is only 2s, little we can think about that. But the entire s square is there. It is joined with s square and minus 4. So totally it is not possible. If it satisfies, then we will write 1 by a. We will extract solving this problem. F of t is our aim. F of t, we will find here some particular term, part of the term or complete term, we will be assuming as f bar of s, for which we will find L inverse. We will obtain first f of t, that t is replaced by t by a. But for us, there is no chance of applying this change of scale property for our given problem. Totally, this format to substitute our problem, it is not fit. So now, multiply and divide by s. Suppose our f bar of s, here it is there. Our f bar of s, it is multiplied by s. Then the eligibility we will test. First, the same, the complete all these theorems. The given problem, we will first obtain f of t. That is, complete the problem, otherwise part of the problem, assuming f bar of s, and we will obtain f of t. That f of t, we will find first derivative. That is for multiplied by s, if the function is multiplied by s. To find this first derivative also, some eligibility it is there. The eligibility is nothing but f of 0 equal to 0, we have to get it. Then we will think over finding the first derivative, that is applying multiplied by s formula. If it is divided by s, the same, we will obtain f of t, but according to the result of divide by s, f of t to be changed into f of u, and we will do the integration with respect to u. The integral range from 0 to t. So both multiply and divide by s also, it is not possible for this given problem. Derivatives and integrals. Now the derivative. This is the formula which is given for derivative. That is, the f bar of s is there. We are doing n times we are doing the derivative. The result is minus 1 power n t power n f of t. So here we have to pick what is f bar of s. The f bar of s, assuming same part of the problem or complete problem, we have to find inverse. Again, inverse to find, these are the possibilities only. All the possibilities we are checking. Nothing is fit. To fit for this derivative also, we will assume some part or complete. Our aim is to find f of t, we have to find. But there is no chance of finding this f of t. So now the derivative is ruled out. Okay, let us try for integral. So the integral means compulsory the symbol should be given. So it is not possible, integral also. So the next, yeah, specific actually it is there. Convolution theorem. That is, two functions we will assume. One part we will take it as f bar of s, L inverse of, from which we will get f of t. Another part we will take as g bar of s, from which we will get g of t. This t is replaced by u. This t is replaced by t minus u. Yes, this is possibility is there, this is possibility is there. The thing it is that numerator. So, very easy way, the fraction of second, taking this problem, just we have gone through. What are the problems related to inverse Laplace transform? We have gone through it now. So, nothing is fit. The totally elementary function, first shifting, second shifting, change of scale property, multiply and divide by s, derivatives and integrals, convolution theorem. So the complete this, how they are fit also we discussed. So the final one is partial fraction. So the partial fraction we studied in lower classes. That is, here we can see the numerator, whatever it is, whatever the terms are given, no problem at all. And we have to see the denominator. The denominator, s minus 5 equal to 0, s equal to 5, we are getting a real number. Coming to the point, thus, s square plus 9 equal to 0, s square equal to minus 9, s equal to square root of minus 9. We are getting this root of minus 1. It's nothing but I form. So the 9 is 3. So the square root of negative, we know it is a complex number. So the numerator, we won't bother. Any term can dominate in the numerator, that is fit for this partial fraction. We will check the denominator. If we solve what we are getting the result in terms of real numbers or complex numbers, that we will be checking. So if it is complex number, according to partial fraction, what is the rule? If it is a real number, What is a rule? So the rules we will discuss. With that, now out of these many inverse Laplace transforms formulas are there, this is specifically, it is fit for partial fractions. So from this, why we selected the numerator saying if it is complicated, s square, s cube, whatever it is there, let us move to partial fractions. So this is our question. Now we will move to solve our given problem. So our given problem, the presentation, how to write given L inverse of s square plus 2s minus 4 divided by s minus 5 into s square plus 9. This is a real number. If it is a real number oriented, then we will write any one variable, capital A divided by s minus 5. Whereas this we discussed just now, s square plus 9. Yes, the result is complex oriented. If it is complex oriented, then B and C, the variables. The question in terms of S variable. So B into S, the next variable C. That is in order we have taken A, B, C. Suppose the problem continues, next we will write D, E, so on. So now we have to find what are the values of this A, B and C. These constant values we have to obtain now. For that, first we will take LCM. So here the numerator of left side, it has been taken here. Then this is the cross multiplication. A of s square plus 9 and here bs plus c and this is s minus 5. We will solve. The solving, any method we can adopt. We are finding here s minus 5 is there. If you take s plus 5, definitely these variables will be cancelled. Our aim is to find the value of A, B and C. So the possibility is taking, the BC is getting cancelled. There is a possibility of getting our A. So main reason that we are selecting, put S equal to 5. So the particular place, S place we put it 5. So this completely we are seeing here. So completely it is getting vanished. So here 25, here plus 10, here 4. So left side it has become 31. Here we are putting 25. So 25 plus 9, 34. So 34A. So A equal to 31 by 34. So taking S equal to the value of S, we have taken 5 and we obtained the constant A value is 31 by 34. So the question which is kept in every slide. So this is the last step of the previous slide. Now here we will substitute now. We are taking comparing the coefficients of s square on both sides. The left side we are noticing s square, the coefficient is 1. Coming to the point of right hand side, the s square, the coefficient is a. So this is 9 only constant. We are concentrating on s square. So if these two, if we multiply, we are getting bs square. So it is b. If these two multiply, we are getting only s. Here also only s. This is only constant. So our criteria is concentrating only on s square. So s square, coefficients of s square on both sides satisfying, we got it a plus b equal to 1. Already we got it the a value, that is 31 by 34. So we are going to substitute here in the place of a. So 1 is as it is, negative sign as it is. A place we substituted 31 by 34. We got it b equal to 3 by 34. So a value we got it, b value we got it. Finally, the leftover is only c. So comparing the coefficients of s on both sides. So if you're noticing here, yes, this is left side, which is 2. Coming to the point, the right side, if we focus, these two, it is not possible because they are related to s square. These two, the possibility it is there, that is related to s minus 5b. Next, these two possibility also it is there, that's what plus c. This is no possibility because there is no s is there. Already b we got the result. That we are going to substitute in the particular place, that is we know it to this plus 5b equal to c. The 2 as it is, the plus and 5 into b we got it 3 by 34. So we are getting 15 by 34. So c equal to, we are taking the LCM. So 68 plus 15 divided by 34, we got it 83 by 34. All the values we got it. That is a equal to 31 by 34, b equal to 3 by 34, c equal to 83 by 34. So all these three values we will substitute where? So we are going to substituting the values of a, b and c, we will obtain. So here this is the place we have taken the cross multiplication and we proceeded. We obtained the values of a, b, c. So those particular places we are going to substitute. What are the results we obtained? So now a is taking 31 by 34, b is taking 3 by 34, and s is as it is, and c is 83 by 34. But our question is L inverse of. This is not a complete problem. Our complete problem is find Laplace inverse of this left side. That is s square plus 2s minus 4 divided by s minus 5 into s square plus 9. So that is the reason we are going to take both the sides L inverse. We have taken L inverse both left and right. But the right side L inverse of one term, this is also one term, this is also one term, because put together they are in under common LCM. But L inverse of three functions, we don't have such formulas. If it is a single one, we have the elementary functions, the basic formulas using, we can solve. So how we can take this L inverse for the three different functions? So we have taken the constants we kept before. L inverse of 1 by s minus 5 plus here also the constant 3 by 34 we kept before the inverse. This is the inverse Laplace operator. So L inverse of S by S square plus 9 plus 83 by 34. That is also kept before the inverse Laplace operator. Now L inverse of 1 by S square plus 9. Fine. Now L inverse of each term we found the inverse Laplace formula. But who helped us? Which formula helped us? The formula which helped us is nothing but linearity property of inverse Laplace transform. Using that property, we can write here f1 bar one function, f2 bar another one, and c1, c2 are constants. So L inverse of two functions are there, that it is written L inverse of first function, L inverse of second function. Using this property, our given problem, we have three functions. So, the first one, second one, third one. So, in a different, that is Laplace inverse, we applied for the three functions separately. Now, this 31 by 34, it is written as it is. This is nothing but L inverse of 1 by S minus A equal to e power 80. Suppose in case if we forget the formula also, L of e power 80, we know it. It's nothing but 1 by S minus A. So e power 80 equal to L inverse of 1 by S minus A. This is exactly fit to our problem. So e power, according to formula, here A is there, ours is 5 is there. So e power 5t. Here it's 3 by 34. This is in the format of, that is L inverse of S by S square plus A square. It's nothing but cos AT. Our A is nothing but the place, A square place, 9 is there. That means 3 square. A is playing the role 3. So cos AT, instead that particular place we are writing cos 3t according to our problem. So our direction, selecting the formulas, if the numerator is dominated by S, our selecting the direction towards S is there, either cos or cos h it will move. So this two we completed. Whereas coming to the last term, the numerator, there is no S possibility not there. So cos h, we no need to think about those two terms, those two trigonometric terms. Then the next possibility is only A. Ours is here, A square is 3 square. The top should be, A should be, that is L inverse of A by S square plus A square. It's nothing but sin 80. According to this formula to fit, A is missing. That means our 3 is missing. We want in this particular, in the place of 1, we need our requirement. It is must for us. Replacing the 1, we have to keep 3 there. But mathematically it is not possible suddenly introducing a real number. We have to balance it. Mathematically, it should balance. Whatever you are doing, it should obey the mathematical laws. So, we will multiply and we will do divide. Now it is balancing. So, this 34 into 3, it has become 102. So, into 3 we did. Here divide 3. This it has become here 102. This complete it has now sin 80 Our A is 3. So sine 3t. We will come to a conclusion of this topic, problems on inverse Laplace transform. We have taken this problem finding L inverse of s square plus 2s minus 4 divided by s minus 5 into s square plus 9. We have gone through completely, once recollecting all the problems, what all related to our inverse Laplace transform. So completely discussing why these formulas are not fit for this particular problem, discussing, we increase our understanding level. Finally, this partial fraction is fit. So we will come to a conclusion that the numerator, suppose s square s cube, whatever the complicated one it is there, or the partial fraction which is completely fit. Only the thing is there, if we solve here, real number we will be getting, here the complex. Complex means how to split. That is also we discussed it. So completely discussing the final result, we achieved it. That is 31 by 34 e power 5t plus 3 by 34 cos 3t plus 83 by 102 sin 3t. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.